So you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there, YouTube. The Dapper Dinosaur here. I guess it's time for more of Karina Altman listing off animals, and then thinking that noticing that they are in taxonomic families means that the story of Noah's Ark isn't completely impossible for basically infinite reasons. Get some popcorn, a drink, and let's get back into the stupid.
All right, so we have so much diversity within the animal kinds today. So, for example, we've got our eagle kind. This is a stellar sea eagle, which is one of the largest and rarest raptors in the world. It has a 9-foot wingspan. You've got the harpy eagle. These guys eat monkeys and sloths. They can fly up to 50 miles per hour and can see something 1 inch wide from 220 yards away. And you've got this Philippine eagle. It can see 8 times better than you can. It has 7-foot long wingspan, and it's one of the rarest eagles in the world. But all of these guys belong to the eagle kind, and those are pretty amazing animals, but very different in appearance and location. So where did all these species come from?
Well, hold your eagles there. Eagles are not a taxonomic group. It's a colloquial term for the largest soaring members of the family Accipitridae, which also includes hawks and even other things called vultures and buzzards, but that aren't true vultures. In fact, various eagles are more closely related to other non-eagles than they are to each other. So not only have you failed yet again to define a kind, you certainly haven't even successfully identified one.
Now, evolutionists today teach that today's animal species have been like this for thousands of years. However, the Bible says that the original animal kinds existed just 4,300 years ago on Noah's Ark.
A time frame far too short to allow for all the mutations it would take to see modern animals. And if mutation rates were for some reason faster after the Ark, you would get too many per animal to be viable, and you'd just see everything go extinct. Mutation has to go at a fairly sedate pace in order for the number of mutations per generation to be something selection can act on in any other way than just resulting in extinction.
So, definitions of species can get a little bit confusing. So the word species originally meant biblical kinds.
Citation needed.
In Linnaeus' day, this was synonymous with kinds. However, later, species began referring to more specific animals.
The majority of species identified by Linnaeus are still valid species, so I don't think we can say that species ever referred to the entirety of Felidae as a single species, as you seem to be implying. If you think it did, please tell us where it was used this way and by whom, because I think you're trying to anachronistically project modern 20th century ideas about creationism back into the 18th century.
So initially, the word species meant something like the feline kind. Now, species means something like jaguar.
Again, citation needed. But even so, we're talking about modern science and our current understanding of biology. So even if a term that is now used in science in a particular way was used in the past in another way, it doesn't really change the current science any. Even the word evolution didn't always have its current specific scientific use at one point.
So there are many variations among animals using the new definition of species. So it used to be just the rhino species, but now we would refer to this as the rhino kind, and then there's 5 species of rhino here.
Wait, what about tapirs, who have nearly identical feet and nearly identical teeth and extremely similar skulls, excepting the nasal region? Or what about horses, who share many similarities in the skeleton, musculature, and especially in the feet and skull? Why can't we have a rhinosauroidea kind? Or a paracedactyl kind? We could include the rhinos, tapirs, chalicotheres, and horses all on the Ark with only a couple animals. And there's the bonus that when they get off, they can all mutate to the point where they look like failed Ripley clones from Alien Resurrection.
So, when theologians talked about species as unchanging biblical kinds, they were challenged. Critics often object to the Bible's accuracy because it says that species are fixed, but we see species changing today.
Well, that's a stupid criticism, because as far as I can tell, the Bible doesn't say anything about species, and it doesn't really say much about kinds, except that they were created. But that doesn't mean they couldn't change.
However, the original definition of species meant created kinds, which do not change, so the Bible is correct.
Except they do change. You said that the cat kind changed into house cats, wild cats, bobcats, jaguars, lions, leopards, cheetahs, etc. Those aren't the same. The ancestor of a jaguar and a house cat wasn't a house cat or a jaguar. Neither of us think it was. So they changed. Sure, not into something that wasn't a cat, but that's how evolution works. things remain inside their ancestral clades, and new clades erupt from within established ones.
In fact, today's scientific community disagrees on the term because new subspecies are forming and species are changing constantly. So it doesn't even really have a solid definition today, but it is currently the most specific taxon of the animal classification system.
Well, it has a few different definitions because different organisms require slightly different definitions. For example, a group of reproductively compatible organisms that can produce interfertile offspring can be considered a species, but that doesn't work too well for asexual or extinct species. Still though, you just said yourself that there are subspecies, and that in fact is more specific than species. For example, Canis lupus is divided into some 9 subspecies, including Canis lupus arctus, the Arctic wolf, Canis lupus familiaris, the domestic dog, Canis lupus dingo, the Australian dingo, and Canis lupus lupus, the Eurasian grey wolf.
However, even with all the change, animals do stay within their kinds, and no new kinds are evolving.
How do you know? You haven't defined a kind. You've given alleged examples, but not told us how you know where the barriers are.
Again, hogs are still hogs. For instance, we've got a bunch of fun pig species in the world today. This is a little warthog. They can live 10,000 feet high on Mount Kilimanjaro and survive months without water. You've got red river hogs, which love to swim, and they also play dead. And then you've got this babirusa here. A lot of people think this guy's pretty funky. They're from Indonesia. The word means pig deer. They're great swimmers. They can eat just about anything, and those tusks can be 17 inches long. But they're all still hogs or pigs, right? They're not turning into anything else. They are staying within their hog kind.
Ah, family Suidae, the old world pigs. Great diverse bunch of successful generalists. But what's that running around in New Mexico, Arizona, Texas, and all through Mexico? It's a little animal that looks like a suid, but it's got the wrong number of toes, and its tusks go down rather than curling up. Oh, it's a javelina, or collared peccary. Peccaries are members of family Thyasuidae. I mean, they sure look like pigs, they act like pigs, they live like pigs. Why aren't they part of the same kind? Is it because someone decided to put the family-level taxa there and divide them up? Why does that taxonomist get to tell God what to do after the fact? I don't know, and since you won't define kind, you can't tell me.
All right, so what caused all this diversity within these animal kinds? We're going to talk about several of the causes.
That sounds like fun, and at least your list of alleged kinds let me bring up neat animals that are closely related to animals that people usually know about, but that aren't actually those animals. So thanks.
So, diversity. God gave his creation incredible genetic diversity. Even though we may have started with only that pair of felines, look at all the amazing cat species and breeds you see today.
Well, each breed of cat has more diversity than could be found front-loaded onto a single pair of cats on the ark. So your explanation of God simply giving them the genetic diversity doesn't really work if we're to assume he just gave it to that initial breeding pair some 4,000 years ago.
Now, animals have the ability to constantly adapt to new conditions, which is very important, especially after the flood, when the world was very different. All that genetic potential God gave them was so that they could adapt to new surroundings, because ecosystems change all the time. So, here's an example. This is one of my favorite examples. This is a saiga. It's a critically endangered antelope from Asia. Look at that giant schnoz.
Okay, I love saiga, and they're really very endangered. So thank you for telling people about them. I doubt they're going to be safe from extinction, but it's still an incredible animal, and I'm glad you've introduced them to people. I mean that sincerely.
It looks ridiculous, right? It looks like a Muppet. However, this is actually very important for this animal because they live high up in the mountains of Asia. That big old nose filters dust and cools down their blood in the summer, and then in the wintertime it heats up air so they don't freeze with that cold air.
So, is it your contention that all the genes needed to produce this big nose were in at least one of the original 2 antelopes on the ark? I sure hope you tell us.
So even though they look kind of ridiculous, this is actually optimal for the conditions that they live in, and God gave them this ability to adapt to their environments. So, pretty amazing animal. All right, so what caused some of this diversity? We see some crazy diversity in the world today, right? Here's an example. This is a legless lizard. They're from Europe.
Okay, nope, no more examples. I'm going to cut the rest of them. She goes on for well over a minute listing off cool animals, and yes, they're cool, but no number of cool animals that exist will by their existence explain her proposed mechanism for biodiversity.
Now, there are several main things that you'll usually hear in science class. There are many different causes. We're just going to talk about the main ones. So first of all, natural selection. Now, natural selection is not evolution, and we'll get to that next.
I guess technically it's not, but it's sort of like saying using the steering wheel isn't driving. Sure, that's true. In and of itself, a steering wheel isn't driving. And in and of itself, natural selection isn't evolution. But both are important parts of the process, and the main way the process is directed.
You'll also often hear mutations, but mutations are not actually really a significant cause, but you'll often hear that it is in science class.
A cause? Well, that's an odd way to put it. Mutations are the source of the genetic variation. And if they're not, then you're going to have a doozy of a time trying to explain why every one of those things you pretend is a kind has too much variation for that to have been all built into a single mating pair on Noah's Ark, or even 7 or 14 animals if they're clean.
Now next we've got selective breeding.
Well, that's not part of the evolution of wildlife, but it is for domesticated animals.
And so we'll talk about all of these in depth in a moment. So new species are always being formed, but there are no new kinds evolving. So again, remember the difference between those two words.
I can't remember the difference. You never told me what it is. You just gave examples that you allege without any particular reason are kinds.
All right, so we're going to talk about natural selection first. So the definition of natural selection is a non-directional process where organisms possessing certain characteristics survive better than others in a given environment or selective pressure.
Well, maybe by non-directional, you mean undirected, since natural selection definitely can and does put directional selection pressure on populations. That's why it changes them in definite directions. For example, if we're going to go with okapis and giraffes as being related by descent, which you've already agreed to, then there must have been some directional selection going on to get such different proportions. But if you meant undirected in that there is no person directing it, then that's fine. It's just pressure from the environment that does not require anyone sitting there and deciding what should be selected for. That's the difference between natural and artificial selection.
So basically, the animals with the most favorable characteristics to survive in their environment will breed, and those without them will die.
No, they'll all die, because that's life. But the ones who reproduce more will spread their genes more, leading to the genetic makeup of the population being different from generation to generation. Natural selection isn't always a binary breed or die. Say we have a mouse population that finds itself stuck on a sandy island. It has enough food, but the surroundings are much lighter in color, and so dark-colored mice are more easily spotted by hawks and owls. Well, that doesn't mean dark-colored mice aren't going to ever breed. But if the average dark mouse only has 2 litters in its life, but the average light-colored mouse has 5, then guess whose genes are going to dominate? Either way, they're both going to die, and both likely by getting eaten by a bird. But the differential reproductive success of the dark versus light mice will mean that there is a trend toward light-colored mice predominating in that local population. In fact, this scenario played out over a few thousand years in deer mice in Florida, who are now predominantly of the agouti color morph. In these mice, melanosomes simply fail to develop, leaving them white or straw-colored and able to blend in the sandy coastal regions they inhabit. Further, scientists know exactly what mutation causes this, so we have both the selection pressure and the mutation.
If the given environment or selective pressure were to change, the characteristics of those organisms will also change.
This is very true and very important. Mutations and traits are only beneficial situationally. Those deer mice would be at a big disadvantage in forests farther north, where the majority of deer mice live. So pointing out, as creationists often do, that a beneficial mutation would be harmful if the environment changed means nothing, because that's the point of beneficial mutations.
So even though animals belong within a same kind, they may look very different depending on where they live.
Maybe, but despite heavily implying that you were going to tell us what a kind is, you haven't.
For instance, let's look at frogs. This is a red-eyed tree frog. They're from Central and South America, and they basically depend on leaves for their entire lives. So they've got those suction toes to stick underneath the leaves. They're green to help camouflage. They actually lay their eggs under leaves so the tadpoles will fall directly into the water when they're ready.
Okay, hold up. Why is it that for mammals, a kind is a family, but then for frogs we're going to put the whole order in a kind? Frogs are at least as different from each other as any two, say, carnivorans are. If we're going to say that the tailed frog, the cane toad, the poison dart frog, and the bullfrog are in the same kind, then there's no reason to say that the mongoose, the tiger, the bear, and the seal aren't in the same kind. Or even a whale, a camel, a giraffe, and a goat. Oh wait, it's because you think that frogs are less visually distinct, so forget the actual diversity. You get to put all those frogs into a single kind and save space on the ark. I forgot, you don't actually care about biology.
However, on the opposite side of the world, you've got this little desert rain frog. It's only 2.5 inches long, but it lives in the deserts of Namibia. And you might not think a frog would do very well in the desert, but they actually have a transparent patch on their stomach that helps them absorb moisture in the sand. And they're actually nocturnal, so again, that helps them stay cooler. They actually sound like little dog squeaky toys. They're pretty cute.
Okay, you're giving examples of frogs. We get it. I'm going to stop you now so you can get to a point.
But again, they're all still frogs. They're not turning into anything different.
And you, a lemur, a capuchin monkey, a tarsier, and a chimpanzee are all still primates. In fact, some of the frogs you talked about are far more different from each other than you are from a chimp. I'm not really sure you thought this through. If order can be a kind, then guess what? Most of the evolution you say is unacceptable is actually perfectly plausible, except there's no way it could happen with the small number of animals on the ark. In fact, if all modern examples of a kind came from the animals on the ark, and an order can be a kind, I guess Noah and his sons and daughters-in-law were not just the ancestor of all humans, but also of all chimpanzees, bonobos, lorises, etc. That's a strange idea. I know you'd reject it, but if we're going to let kind be a whole order, why? It's not any less reasonable than all the frogs coming from a single mating pair of frogs on the ark. In fact, given that there's more genetic diversity in frogs than in any mammal order, it's more reasonable to say that all primates descend from Noah than it is to say all frogs descended from a pair on the ark.
So actually, one of the men who has the best definition of natural selection is Charles Darwin himself in his book, Origin of Species. There is a constant struggle for survival because of population growth and limited resources, and certainly each kind can produce many varieties. Therefore, there will be survival of the fittest, or natural selection of those varieties of a population that fit best into their environments. Given enough generations and the right trait combinations, organisms that seem designed for their environment will simply result from natural selection. This is the correct definition, but again, this is not evolution.
I mean, it's not track and field, and it results in changes in organisms from one generation to the next, due to changes in allele frequency, so I think it is evolution. But I also think that that's all we've got for this episode. Please come back for the next one, and if you like this video, please hit the like button, and if you're not already subscribed, please do so. Thanks for watching. But before you go, I'd like to take some time to thank my patrons, especially my $20 and above patrons. Ian Chen, Chris Love, Henry Hutanen, Bob Knob, The Evil Scotsman, and Benthoven. As you know, YouTube is a very volatile platform, and my patrons give me much needed stability. If you'd like to join the team, there's a link in the description to my Patreon, which starts at $1. If you'd like, I also have a link to my Teespring store and an Amazon wishlist.
So you found the skeleton. How would you tell people that you personally? How would you decide?
Well, interesting question. I don't know.